So, when it came to solving matrix equations or properties of matrices, remember we had this thing. We showed some examples where A times C equals B times C, but A is not equal to B. Right? This scenario was possible. Right? We showed some instances of that. However, there is a time when this sort of thing is possible to do. Alright, so what we have here is a property or a theorem. And I'm going to call these cancellation properties. Alright, so if C is invertible, right? So in the case that we actually have an invertible matrix, C, then we can cancel, basically. So here, if AC equals BC, then A equals B. All right, and 2, if CA equals CB, then A equals B. All right, but again, keep in mind that this is only true if C is an invertible matrix. So you are allowed to cancel out. However, you must only be canceling out an invertible matrix. Okay. Now here's a word of caution here. Right? It is still, let me even capitalize that. So it is still not true, at least in general, that something like AC equals CB implies A equals B. And CA equals BC implies A equals B. Right? These are very much not true. Okay? Now think about why that's the case. All right, so here, we can only cancel on the right or on the left. Here, C isn't on the same place. In this equation, it's on the right here and on the left here. In the second equation, it's on the left here and on the right there. If the C is not on the same side on both sides of the equation, we cannot cancel it. All right, keep that in mind. So let's do a little proof of this. So proof of, say, the first property there. Right? So if AC equals BC, right, then we can multiply both sides by C inverse. Right? And we can then use associativity. All right? And then, well, we know that C times C inverse is the identity. So this tells us we get A times the identity here, and B times the identity here, which says A equals B. All right. So this is generally how these things work. Now, why is that important? Why is that important here? Well, the reason we care about cancellation here is we're going to use the same idea to solve matrix equations. Right? So if we have the system of equations, well, specifically linear equations, right, that we can write as AX equals B, okay, then what we can do is follow a similar logic. So if AX is equal to B, then we can multiply A inverse on both sides here, All right. But again, we have associativity. And so, you know, I'll just skip writing the identity here. All right. Now this works if A is invertible. All right. So this tells us something very interesting here. Notice that this is the only solution. All right. So we get the property here. Actually, I'm going to even call this a theorem. All right. So if A is invertible, the system, right? The system AX equals B has a unique solution. Specifically, X equals A inverse times B. Right? And that's what we've sort of shown up there. So we can use this to solve systems of equations. So we'll do that in the next video. But hopefully this makes sense.